And today we'll have Juan Miguel Velásquez and Pablo Guarda for the World Resources Institute at the Ross Center for Sustainable Cities. Um, Juan Miguel works as a senior associate, and Pablo Guarda is currently a transport research intern. The talk that they are going to give today is called Rethinking the Next Generation of BRT in China.
So good morning, everyone. As Nicolas mentioned, we're here in DC. This is Juan Miguel Velásquez speaking. I'm here with Pablo Guarda. We'll both present um, a finalized, almost finalized version of this piece of work that we've been doing on rethinking the next generation of BRT in China. Um, as Nicolas was mentioning, this project is a collaboration between WRI Ross Center for Sustainable Cities and Pontificia Universidad Católica in Chile under the BRT Center of Excellence. So let's start. Why are we focusing on public transport in China? There's a great urgency to develop public transport there. If you look at the projections by the International Energy Agency, China is set on a path where motorization is going to grow at a very fast pace. We're currently at about 480 vehicles per thousand persons, according to the IEA, and we are set to reach 5 times that, for almost 400 vehicles per thousand inhabitants in China by 2050, if things continue as they are going. So if we want to move to a 2-degree scenario of global warming, we need to curb motorization and especially car usage, and public transport becomes a very key and essential tool to achieve that. On top of that, China has signed international agreements to reduce carbon emissions. In this case, China signed a commitment to reduce CO2 emissions per unit of GDP by 60 to 65% compared to the 2005 baseline in the last Paris Agreement in last year. So public transport is a key milestone, and of that, BRT is one of the components that can help deliver these commitments on CO2. But on top of that, you can see that China has been one of the countries that has added BRT at a faster pace than any other country in the world in the last 10 years. Likewise, they've been building metro also at a very high pace. So public transport is at the core of China's strategy for urban development in terms not only of emissions, but to tackle other problems such as congestion, pollution, air quality, road safety. So public transport is one of the cornerstones of the strategy to improve the quality of life in cities in China. So that said, going into BRT, which is specifically what we're looking into as one of the components of public transport in Chinese cities. So China has made a lot of advances in increasing coverage of bus rapid transit in Chinese cities. They still have a long way to go to do that, but they have made great steps. But today, the challenge is not only about coverage, the challenge is also about service quality and performance of public transport. If you look at many of the systems today, there are big challenges in public transport. This is a picture in Kunming, where you can see that even though the volumes are not as high as bus rapid transit systems in other countries, they're still having service problems of very long queues of buses, and therefore very slow speeds and not the best performance that could be had. So what we set out to do in this study is to try to compare design and performance indicators between Chinese and non-Chinese BRTs. Are Chinese BRTs outperforming or underperforming when compared to the rest of the world? So to do that, we start exploring the relationship between design features of BRTs and their performance. And we do that in order to identify specific design elements that need improvement and that where there's opportunities for improvement of the performance of Chinese BRTs. And we try to also go even a bit beyond that and try to identify priorities and quick gains for design features, specific design features that will provide quick gains. How we do that? So we did this study, and we might hopefully move beyond step 3, but so far we've done these 3 steps, which is data collection and cleaning. As Pablo will mention later, data collection has been a big part of the study, and a lot of efforts have been devoted to gathering data, given the availability of data not only in China but in the world, and making it compatible. So the processing of the data has been very thorough and very complete, but not a task that is ongoing and that will, it seems, an endless task. So after collecting and cleaning this data and trying to make it compatible and usable for our analysis, we are then using it to assess the strengths and opportunities of Chinese BRTs when compared to the rest of the world as a benchmark group. And lastly, we're trying to quantify the impact of improving some of these weaknesses and some of these strengths on performance. So how if China achieved levels similar to the rest of the world, how would these features impact the performance of Chinese BRTs? So as I mentioned, we are using several data sources. We're starting with data sources from BRT Data, which is the observatory that we run out of WRI cities in partnership with the BRT Center of Excellence and with the funding from Volvo Research and Educational Foundations. And so that's the observatory where we have basic data and almost 100 indicators, more or less, for each one of the cities. But we combine this with the ITDP, the Institute for Transportation Development Policy BRT Standard. In this case, we use the 2013 and 2014 editions. There's an upcoming edition, 2016 edition, which will be launched, I believe, next week. And there's a webinar organized for that. So hopefully we'll be able to also use some of that data. And when we joined these 2 databases to try to get the best data, we ended up with 99 observations. That'd be system or corridor level information in 21 countries and 59 cities. That leaves us more than 1,800 kilometers of BRT infrastructure total. And we looked at different performance measurements. We looked at speed, frequency, throughput, but we would be reducing our sample size hugely, and also the availability and the quality of the information wasn't available for all the systems. So we ended up using productivity as our measurement of performance for this study. Hopefully we would be able to, in future stages, expand it to other measurements of performance. And productivity we measure as a function of the passengers, daily average passengers in a corridor, divided by the number of kilometers of infrastructure of the bus corridors. So just to tell you a little bit of how we measure, so we have this performance of measure, and how do we measure design features, is we use the BRT standard, which has 7 categories that rate different design features of infrastructure. BRT basic, service planning features, infrastructure features, features related to design, issues around communications, and access and integration, and then there's a few point deductions related to service provision. Each one of these 7 categories are broken down into 38 subcategories, which in the end give a ranking of BRT basic, bronze, silver, gold. These 38 subcategories are evaluated by experts from ITDP and given a score. And these are the scores that we use to rate the different design features, and we then combine it and compare them with a performance that we obtain from our BRT data observatory. And so in the next webinar, we are not going to go into a lot of details of what each one of these features exactly mean. We can answer the questions. But the next webinar next week will go into a lot of the details of what each one of these categories go, and we'll introduce the 2016 edition, which will have an improvement versus these versions in terms of what is evaluated. So again, just to summarize, we have 99 corridors and systems. We have a very good representativeness of the Chinese systems. We have 23 corridors or systems for China, and we have over 500 kilometers for China. So we have a good representativeness of Chinese systems and also of the world benchmark group for this study. And to go on to the step 2 and onwards, I'm now going to hand it over to Pablo Guarda, who's going to tell us a little bit more about the details and the findings that we've obtained.
Thank you, Juan Miguel, for the introduction, for my introduction. And I will talk now about the step 2 of this process. So the objective was to assess the strengths and opportunities for Chinese BRTs based on a comparison of the score obtained in the BRT standard. So we use our input data, the evaluation of BRT corridors and systems available in the ITDP standards edition 2013 and 2014. And the output was the average score difference among the BRT design indicator between the target group and the benchmark group. The target group was the Chinese BRTs, and the benchmark group was all any other BRT corridor or system available in the BRT standard. So we know, like, there are some studies in which compare China with South America, and our methodology could replicate this by using as a benchmark group the South American BRTs rather than BRTs, non-Chinese BRTs around the world. In addition, so the score difference are very helpful to realize when China have a strength or weaknesses, which are finally opportunities for improvement. But it's very important to assess if these differences are significant, and because this difference could be obtained purely by chance and not because a difference exists there. So to assess if there was a statistical difference there, we use a traditional method as ANOVA to compare the variance across the values of the indicator in each of the groups. And as we talked, we use as target group the Chinese BRTs, corridor system, and the benchmark group, the non-Chinese BRTs. So we ended up with a chart in which we have in the first 7 rows, we have each category within the ITDP standard: communication and marketing, station design, station bus interface, the point deduction category, BRT basics, service planning, interaction and access, and infrastructure. And then we also, in the last 2 rows, we have the score obtained by adding the score in each of the category in the BRT standard. But note that each category have a different weight, which is represented by the total score that is assigned to each of the category. And then we have the total score, which is which also include the point deduction. Point deduction are grouping subcategories that are related more with the operation of the BRT corridor. So generally, this evaluation can be conducted once the corridor is in operation. Most of the subcategories in the other categories of the ITDP standard can be obtained without having a BRT corridor operating. So the difference here is we transform the scale of the scores because of difference in the scale used between 2013 and 2014. So to make it comparable, we use a scale between 0 and 100 for each of the categories. And here, here is the difference between Chinese and non-Chinese BRTs across all the categories. In blue are the difference that were statistically significant based on the ANOVA analysis, and in gray are those which were not statistically significant. If this difference were significant and positive, we call them a strength of the system, and if these difference were negative and significant, we call them a opportunity for improvement in Chinese BRTs. So then we replicate this analysis, but using the score in each of the subcategory of the ITDP standard, and using again a scale between 0 and 1 for each of the subcategories. In this slide, we have the result obtained for the subcategory within the BRT basic, service planning, and infrastructure categories. And for example, we can see in the category BRT basic, the subcategory intersection treatment obtained a score significantly lower in Chinese BRTs compared to non-Chinese BRT, and this analysis was replicated for each of the subcategories. In this slide, we have the results for the subcategory, so for the categories station design and bus interface, communication and marketing, and integration and access. And in the following category, in the following slide, we have the result for the point deduction category. So in step 2, we assess if there were different scores and if these different were significant in terms of in statistical terms. But the scores itself doesn't represent anything. It's just an abstract scale with a not meaningful scale. So to convert the scores in terms of performance, or basically find an association between design and performance, we estimate a regression model based on the data available. So in the simplest approach, we use a simple linear regression model, SLR model, to link productivity and scores in BRT corridors and system within the ITDP standard. So here we have as explanatory variable the final score obtained by a BRT corridors and system, and as a dependent variable the productivity for that BRT corridor system based on the productivity information in brtdata.org. But this analysis, the later analysis, assumed that a certain difference in the score in any of the categories of the ITDP standard had the same effect on productivity, because we were using only one estimated parameter to measure this impact. But we tried a second approach using a multiple linear regression model to capture this a potential heterogeneity in the impact of the score in each of the subcategory over productivity. So we add one explanatory variable for the score obtained in each of the category for a given BRT corridor or system. And again, we use as a dependent variable the average productivity of the BRT corridor or system in the ITDP standard. So here to see visually the correlation between the score obtained in the BRT standard, or equivalent to the a proxy of the design of the BRT corridor system, and the productivity, which was used as a proxy of performance. We disaggregated, we aggregated the observation at the level of cities. And so we picked all the BRT corridors and system at a given city. We calculate the average score of those corridors and system and the average productivity. And in addition, we disaggregated Chinese and non-Chinese cities to see if there were differences in the absolute value of the correlation between design and performance using as proxy BRT standard and productivity. If we assume a causal relationship between these two variables, because here we are basically, we can't assume that necessarily, but if we assume it, we'll see the same at a given increase in the score in the BRT standard, it should lead at a better increase in productivity in Chinese BRTs because the slope that is given for the parameter beta is higher in Chinese BRTs. In addition, we can see the goodness of fit of the regression line for Chinese BRT. It's higher than the goodness of fit obtained for the non-Chinese BRT, which could be explained because Chinese BRTs are more similar across them, so you would expect less variability. And in addition, the higher value of the slope could be explained basically for all those factors that are not related with the Chinese BRTs, with Chinese BRTs itself, but for example with the density or the willingness to use public transport in China that lead at, if you build a BRT, then you would expect higher demands and then lead at a higher productivity for that fact. So here we have the regression model results. In the first we have two models: the SLR model, which is the simple linear regression model, and the MLR model, the multiple linear regression model. Each model was estimated using different samples. So in the first case, we use only information from Chinese BRT corridors or system. In the second column, we have estimation only with the non-Chinese BRTs. And in the third column, with all the observations. And again, the same analysis for the simpler linear regression approach. So that's why the sample size is different in each case. Here we have the explanatory value we use for each model and the intercept, and for each model the number of observation and the R adjusted R square for each model. For our further analysis, we use the result of the MLR model using the data from Chinese BRTs because we want to calculate the difference in productivity due to the different score for China. So using this sample size, the beta should represent better what would happen in China if the scores change and how this impacts in productivity. But there is a trade-off here, because if we only use the information from China, the sample size, the smaller sample size lead a lower statistical significance in the parameter. So that's why we see here in the MLR model using information from Chinese BRTs, only one parameter was significant, even though the other parameter had positive sign and a level of significance that are higher than 40 of 50%. But in this case, we only choose the parameter that obtained was significant with a level of confidence of 95%, which in this case was the access and integration category. So here we have the results, and based on the difference in scores between Chinese and non-Chinese BRTs, we calculate the difference in productivity, weighting the score difference by the beta corresponding to each of the subcategories. Because we use one beta for each of the category, we had to link, we had to see what category corresponds to that, to a given subcategory, and then use the weight to convert scores in productivity. Because in the multiple linear regression, only one beta parameter was significant, then only we could say that only some score difference in the subcategory should lead at a difference in productivity. even though the score difference in the other subcategory could produce difference in productivity, but we have a problem. We have a problem with sample size that we would expect to correct to overcome in further analysis if more information is collected in further edition of the BRT standard. And Juan Miguel will explain later a summary of the results. So here we have the same analysis, but for the subcategories in which so there is a question here. This average impact in BRT productivity subcategory is only for Chinese BRT? Yes, that's correct. It's only for Chinese BRT, and that's why we use the beta obtained in the multiple linear regression using data only from Chinese BRTs. But this analysis could be replicated for any benchmark group across the world. But because our project the focus is in China, we perform this analysis for China. And here in this slide, we have the same analysis, but for all those categories in which China obtained a lower score than the rest of the world, and we convert the different score in losses in productivity. And in this case, the universal access represent a loss in productivity of almost 20,000 passengers per kilometer. So now Juan Miguel will talk about the main result of the study and the policy implication and the next steps.
So maybe to further answer Gabriel's question, I think that this analysis, so the purpose of today's analysis is to compare Chinese BRTs versus the benchmark group, which in this case is the rest of the world, in order to provide recommendations or understand the strengths of Chinese BRTs. However, you could do this for any other two groups. You could compare Brazilian BRTs versus the world benchmark or the Chinese benchmark and provide these impacts in BRT productivity for any other group. So you could use the same methodology for other groups. However, for this, the scope of this study is only to do this for Chinese BRTs. But Pablo, at the end, if we have some time, might show you a little bit of what we've done to try to apply this methodology for other systems if we have some time, but I think we're a bit short on time. And so just to summarize a little bit about the conclusions that we have. So the category of integration and access is one of the ones that we feel that is the one where Chinese systems can have quicker gains on productivity if they address some of the problems that we've seen there. Specifically, universal access and pedestrian access seem to be the categories that we hypothesize that are where the most of the improvements can be made. And that means wheelchair access for those with physical or impairments to access the systems, as well as just the integration with the urban development such that pedestrians can access the systems very easily. That's where it seems that most of the quick gains can be had in Chinese systems. There's other subcategories that we feel that are very important. For instance, the intersection treatments are ones where Chinese BRTs obtain significantly lower scores than non-Chinese BRTs. When we looked at this in terms of productivity, we didn't find a statistically significant result. However, the difference is statistically significant. So we do feel that maybe with better data, we would find, or with a data that's not so variable as what we found, we can find better results there. But definitely there's work to be done in intersections of BRTs in China. And we find that there's a lot of phases, perhaps the coordination between the traffic police, which is in charge of the intersection and the traffic light system, and the transport operators and the transport planning is not working very well. So maybe part of the future work of this, of the remaining of this project, is to dig deeper into each one of these findings and see what can we done specifically, why are some of these results happening, and hypothesize on what exactly could be the specific improvements that could lead to these improvements. So to conclude, we are identifying priorities to improve the standard of Chinese BRT system based on the international benchmark and therefore on international practices. We're also using regression models that allow us to quantify how these improvements would affect productivity of the BRT systems and improve ridership in this case. And another important conclusion and important finding of this study is that we're using the two largest data sets that exist out there on BRT, which is the ITDP Standard and the brtdata.org observatory on bus priority corridors, to perform quantitative analysis, which we feel is an important contribution that this study brings to the state of the art of knowledge on BRT. That said, there's a lot of further research that should be done. One of it is including data from the ITDP standard that will come out next year and that will help us increase the sample size and maybe introduce new categories of analysis, depending on what's launched out there next week. Likewise, we should do a performance sensitivity analysis to further test the robustness of our analysis. And we're also working on implementing an online dashboard that, as I mentioned earlier, to answer Gabriel's question, is a dashboard that can help us do this sort of analysis, not just for Chinese versus the international benchmark, but also any target group versus any benchmark group. So we could compare Chinese systems versus the systems that we consider are the best international practices. So we could compare, for instance, gold systems versus Chinese BRTs and further flesh out recommendations, or we could just compare any other group, Brazil versus other countries, if that's something that Gabriel would like to do. So hopefully we'll have this online dashboard that will do that, and for now we have a beta version out there on this. And likewise, a further step on this project, which still has a little bit under a year more to go, is to try to water down or to try to filter down these recommendations and come with very specific reasons of why are intersection treatments or why is universal access a problem, why is pedestrian access a problem, and try to come with very specific recommendations on what this new generation of BRT in China could come. And likewise, we should include new systems like the one in Yichang that seems to address a lot of these issues that we found here and see if that is the way to go in the future for Chinese BRT systems. So that said, I wanted to acknowledge the BRT Center of Excellence, which is the coordinator of this project, which is funded by the Volvo Research and Educational Foundation. So we want to acknowledge them for their support of this research project. And here are some of the citations, and I understand that Nicolas is going to post this online and share the PowerPoint in case you want to look at this later. And likewise, we are also available by email if you have any questions if you want to access any of this data or any of the further analysis. We hope to produce a paper out of this that will be hopefully published and be publicly available for everyone to understand the details of the methodology. So I just wanted to thank everyone for attending our webinar and perhaps open it now for Q&A.